Hi, everybody, and welcome to Seed Speaks. This is a video series brought to you by Seed World Group. My name is Marc Zienkiewicz, and I am an editor with Seed World Group. And this month, we're talking with experts about the future of plant breeding. I'm joined today by some very special guests, the three winners of the 2023 Canadian Plant Breeding Innovation Scholarships. These scholarships go to deserving young plant scientists who represent the future of the plant breeding discipline. This year's winners are Ritesh Yadav at the University of Manitoba, Jerome Belanger, McGill University, and Loveleen Dhillon, University of Saskatchewan. Hi, everybody. I just wanted to quickly mention that these scholarships are made possible through a variety of great sponsors. On board as sponsors this year are Alberta Wheat and Barley, C&M Seeds, Canadian Seed Growers Association, FP Genetics, Germination, Nutrient Ag Solutions, Richardson, Saskwheat, Secan, Warburton's, Western Grains Research Foundation, and Seeds Canada. Welcome, everybody. How are you today?
Hi, thanks, Mark. I'm good.
Hi. Thanks.
Thanks for having us. Thanks.
Well, nice to see all of you. Now, as I mentioned, the three of you represent the future of plant breeding. You all have recently completed or are working on your PhDs, and you each study unique areas that impact specific crops. First, I just want to tell our audience why your research is so important. But before we discuss that, I want to give people an idea of why young people today are getting into plant science and plant breeding in the first place. In a nutshell, I just wanted to ask each of you what inspired you to be a plant breeder. I'm going to start with you, Jerome. Can you tell us what inspired you to be a plant scientist or a plant breeder in the first place?
So yeah, my main inspiration to be a plant scientist is that my father and many members of my family have either been farmers or foresters or both, and they taught me to really appreciate plants and farming for the vital roles these play in our society. So with the years, I really developed a deep love for plants, agriculture, farmers, and rural areas, and I just decided to keep on studying to make a difference in this sector.
Ritesh, what made you want to get into the whole plant science game?
Well, I was born and raised on farms in eastern plains of Nepal and have seen my family and villagers facing severe crop losses due to crop disease and pests and several abiotic stress. And those losses, of course, could have been significantly reduced if we had some resilient traits and better varieties, and we would not have to suffer a lot. So those bitter farm experiences in my childhood and uh, strong desire to improve my farm production actually triggered me into the plant science, triggered my interest, and motivated me to pursue a career in plant science.
Loveleen, how about you?
My story actually resembles Ritesh and Jerome. I was born and brought up in Punjab, a state in northern India. Agriculture is the main occupation of people there. So I was also born and brought up in the family of farmers. My father used to tell me stories about how agriculture has changed from the time when he was born and how it has evolved since then. And I always knew that I have more interest in the plants. To pursue that interest, I joined Punjab Agriculture University, and I got to know about green revolution there. And I was very much fascinated by the role plant breeding has played in changing the wheat and rice cultivation worldwide. So I think that's where I got the motivation to pursue my career in this field.
Now we're going to get a little bit technical and discuss your work specifically. And this time I'll go in reverse order. We'll start with Loveleen. Loveleen, your research broadly addresses the challenge of improving nitrogen fixation in P. Now, nitrogen fixation is a major benefit of legume crops, and expanded use of legume crops in cropping systems is a critical approach to reducing greenhouse gases to address climate change. Loveleen, can you tell us a little bit about why your research is so important?
Absolutely. So, as you have mentioned, that legume crops have they have the tendency to fix the atmospheric nitrogen with the help of symbiotic associations. So, pea being a legume crop can fix atmospheric nitrogen, and it can satisfy its nitrogen requirement through this process, and it also leaves a nitrogen-rich site for the subsequent crop. And especially in the current scenario where we are dealing with the detrimental effects of these nitrogenous fertilizers, and also these nitrogenous fertilizers are one of the most expensive input in our agricultural systems. So my research, which focuses on improving the nitrogen fixation potential of pea crop, will definitely help to present pea as an alternative crop option, a sustainable crop option in the currently dominated cereal and oilseed cropping systems of Canada, and it will it will reduce the dependence on the nitrogenous fertilizers, and will definitely help to address the environmental pollution that is caused by the nitrogenous fertilizer, and also leads to decrease in the crop production costs overall.
Now, Ritesh, you're doing research into the development of genomic selection models for fusarium head blight resistance and winter hardiness in winter durum. Now, this is a potential new class of wheat being developed in Canada. There's only ever been one winter durum variety registered in Canada, from what I understand. Ritesh, can you give us a short synopsis of why you're doing this?
Sure, Mark. So genetic improvement of fusarium head blight resistance and winter hardness, which are two priority traits in winter wheat breeding program, is actually super challenging due to their complex inheritance, extremely time-consuming, labor-intensive, and costly phenotyping requirements, and need of repeated multi-location data over the years to reduce the estimate the biased estimate of the selection uh, candidates. So the development of robust genomic selection models, it actually will exploit the genotypic data. And in the recent times, the cost of genotyping is really cheap, and subsequently it will enable screening of large durum germplasm with fusarium head blight resistance and winter hardness without large-scale field phenotyping, and therefore the selected non-phenotyped material can be used for developing elite winter durum cultivars with improved fusarium head blight resistance, using less money, less time, and less resources, thus making winter durum cultivars a reality in Canada in the future.
Now, Jerome, you're currently working to understand how to develop extra early soybean varieties to enable cultivation in regions like northern Saskatchewan and Alberta, where maybe soybeans haven't been grown very much before. Can you talk a little bit about why we need to do this?
Yes, sure. So, as you may all know, soybean is a very important crop worldwide. But living far north limits really the number of crop we can grow, which includes soybean. Here in Quebec and Ontario, soybean has been grown for quite a long time. But in the prairies, it's been very recent that soybean has been introduced in the rotation of the farming. In farming. So, as you all know, soybean is an increasingly important source of protein in human nutrition and Western diets, and it also plays an important role in livestock feed as well. The crop is important because it fixes nitrogen, and it also has quite a quite a higher oil content compared to other pulse crop and leguminous crops such as peas. For farmers in the western prairies, the ability to grow soybean can mean an additional nitrogen fixing crop in their rotation toolkit. which also means that they can generate interesting profit margin out of this crop. So I think my research is interesting just because it can introduce something that could be a real game changer for farmers. But a lot needs still to be done, and I'm trying to participate in this work. So yeah.
Now, as you've all explained, you're working in areas that are important to the future of the seed industry and farming. Your research could create new opportunities for the pea, soybean, and durum industries and people who grow these crops. You've all been very productive and successful in your work, but you've no doubt faced a lot of challenges, right? I'm curious what the biggest challenges that you face as a plant breeder and how you think that challenge might be overcome for others who face the same issue. Let's start this time with Ritesh. Ritesh, what's the top challenge you face as a plant scientist, and how do you suggest that we as an industry can change that?
I believe the top challenge many plant scientists, including me, face is inadequate research funding, as plant science is often a lower priority in research funding compared to other areas. And to address this challenge, I guess industry could invest more in plant science research and help us to build a sufficient fund for doing novel research. And additionally, I think industry can play a crucial role in promoting collaboration between different organizations and institutions. And in doing that, we can easily pool resources more efficiently. And further, I believe industry can also promote public awareness and understanding of the importance of plant science research to build support for increased investment in this field.
Jerome, how about you? What's the biggest hurdle or roadblock that you face in your work, and how can we maybe help get over that?
Yes, actually, I would say the same thing as Ritesh. I think the funding is a really important issue in our sector, especially in Quebec. I don't know for the rest of Canada, but ear farming has been kind of marginalized in almost any sphere, whether it be at the government level, the academic level. I think there's quite a lot of lack of funding. I think what like the industry should do to alleviate this problem is maybe try to create these partnerships with the academia and with the other institutions to try to just bolster a new network of that could encourage young people to get into the plant breeding and plant science game. Just because at this point, I feel for Quebec specifically, there's quite a lack of incentive for young people to get into this business. So yes.
Loveleen, how about you? What are your thoughts
Um,
on that?
I think I kind of agree with Ritesh and Jerome. I think that being a plant science student, I always feel that we are less connected to farmers because we get opportunities to interact with scientists and our fellow students. But I think if industry could help in arranging some extension events where which brings together the students, farmers, and the scientist, and I think that will help every student to get real life experience of the farming situation, and I think that would help students to students like us to do better and think about it in as a real experience. Secondly, of course, talking about funding, yes, I think that there is a lack of funding, especially to the students in their early careers. Once you finish your PhD and then you start as postdoc, I think financial security there would also help the early career scientists like us to perform better, and it would encourage us, and especially if we happen to be successful plant breeders in the future, stable fundings for agriculture. And also in my, if considering my research, I would like industry to put incentives into popularizing a legume crop, intercroppings into our agricultural systems.
Now, as I mentioned earlier, this season of Seed Speaks is all about the future of plant breeding. And I'd like to know what excites each of you the most about this field of study when you think about the future and the potential of your research and of plant science in general. I'll start with Loveleen this time. Loveleen, when you think about the future of pea as a crop, what makes you feel really excited about that?
I think being into pea breeding, I think pea breeding has an exciting future. Firstly, because Canada is one of the largest producers and exporters of pea, so it definitely plays a big role in the economy of the country. Secondly, because of its ability to fix atmospheric nitrogen, it is a sustainable, excellent sustainable crop option. That is what we are seeking these days. And thirdly, with the recent interest in the Beyond Meat products, pea has an exciting role to play there, because also in our study we found that improved nitrogen fixation leads to more accumulation of protein in the pea seeds. So definitely yes, it has a great role to play in the industry as well. So yeah, I am excited about the future of this of pea breeding.
Yeah, plant-based protein has certainly been been in the headlines a lot, and have sort of raised the profile of pea quite a bit. Ritesh, how about you? When you think about the future of durum and of wheat in general, what really gets you fired up?
As we know, more recently, a field of genome editing, high throughput phenotyping platforms, data analytics, machine learning, they're rapidly evolving and have showed some huge prospect and potential for increasing genetic gains in crops. And for wheat, we know that a lot of research work has been already done, and the yield gains, they are relatively stagnant as compared to other crops. So when I think about the future of wheat, I guess practical applications of genome editing technologies for enhancing the gains in wheat yield, as well as nutritional value, and improving the overall crop resilience to climate change, really excites me the most.
Jerome, I don't have to tell you, Jerome, that soybean is like wheat is a massive crop for Canada. I'm sure that there are a lot of people, Jerome, very excited by your research. If we can enable cultivation of soybeans in parts of the country where they haven't been grown before, I'm sure that's hugely exciting for a lot of people. What do you see coming down the pipe in the future, Jerome, that makes you really excited about soybean?
So I would say that on a fundamental scientific level, I think we are making quite a good progression in taming the soybean genome. And I think with new technologies such as CRISPR, it offers really new opportunities to breed specific traits such as disease resistance in soybean. And also the pool of information is constantly increasing for soybean. We now have quite a lot of information concerning the soybean genome. On a practical level, I think that it's really very inspiring to see the progression of soybean cultivation in the prairies. This opens doors for scientists like me, and I think it will reconfigure the whole sector in its own. Because as you all know, in Manitoba now they're growing quite a lot of soybean. Even they're cropping even more soybean than in Quebec currently. And I think it's really interesting. And I think in the future, if we successfully include tools such as genomic selection, CRISPR technologies, and all kinds of different tools that we are currently developing at the academia level will be able to be very competitive, and this will ensure a really nice future for soybean cultivation in Canada and Quebec.
Before we take an audience question and sign off for the day, I just wanted to ask you guys one more question. For those young people thinking of following in your footsteps, what's your advice on how you can be a successful plant scientist or plant breeder? I'll quickly go around the table. We'll start with Jerome this time. Jerome, what makes a successful plant breeder these days?
So I would say that it's really important to cultivate your love for plants, for agriculture, and for farmers. Try to understand what the farmers want to grow, because ultimately it's them who will decide if your variety is successful or not, no matter how good you are in the lab or at crossing plants. Uh, yeah, I think these are really required to be a successful plant scientist nowadays. Try to read as much as possible, because the field is evolving quite rapidly these days, and it's really important to at least have a grasp of what is happening in almost all the crops, just because it's evolving extremely rapidly. So I think these are the requirements to be a good scientist nowadays.
Loveleen, what do you think?
Yeah, I will add to Jerome's, like, yeah, you should have knowledge, and then you should be ready to work hard and have patience, because sometimes you have to accept what was unexpected. So this is definitely a dynamic field where you get a lot of opportunities to learn from your failures every day. So you should be open to learn from your mistakes, and hang in there with patience and hard work.
Ritesh, what's your opinion?
I would just like to add some few things. I guess keeping yourself updated with current research and development in plant science, and of course, building strong collaboration and networking with other researchers. They are also very crucial, because I guess nobody is perfect, and we always need some advices and mentorship from different people around the globe. So, yeah, that's from my side.
Before we sign off for the day, we have an audience question. I'm going to start with Jerome on this one, because you touched on this a few minutes ago, Jerome. Ashley Robinson asks, are there any newer plant breeding techniques that interest you and that you would like to work with in the future? Jerome, you're talking a little bit earlier about CRISPR, etc. Can you give us your thoughts on that? What's if you had to pick like one new breeding technique that you could work with, what would it be?
But personally, I'm currently working with CRISPR, and I think there's quite a lot of studies that are touching on CRISPR for soybean, touching on the breeding aspect for soybean with CRISPR. I think CRISPR will be very revolutionary in the future. We're only starting to see its potential, and I think for soybean, for example, it will help us just develop specific traits that are really required for soybean cultivation, because soybean has its own specific issues regarding soybean cyst nematodes, sclerotinia, and all the different diseases. So I think CRISPR will not replace, because a lot of people are saying that it's going to replace, but it's going to be complementary to what we're currently doing with conventional breeding and all these new tools that are slowly appearing in the landscape, such as genomic selection.
Ritesh, if I said you could have one new technique or technology to do your work with, which one would you select?
Uh, I think I would love to work on high throughput phenotyping platforms. So, because mostly with plant scientists, we face a lot of difficulty in phenotyping, and a lot of errors are there due to multi-location trials, and different peoples are involved. So, I guess development of cost-effective high throughput phenotyping platforms would be the area I would be really interested to work in combination with genomic approaches. Yep.
Loveleen, I'll give you the final word.
I think, I would like to work with genomic selection, which will reduce the time for any varietal release, and also I would like to opt for the techniques that that makes agricultural phenotyping more digital. That will save a lot of time and efforts that we put out in the field.
Well, that's all the time we have today, guys. Thank you so much for your insights today. It was great to talk with you. Thank you for joining me, and congratulations on your scholarships, guys. You deserve it.
Thank you.
Thank you
so
for
much.
having us.
For having us.
Thank
Yeah.
you. Yeah, thanks.
And once again, before we sign off, I just want to thank our sponsors of the Canadian Plant Breeding Innovation Scholarships, Alberta Wheat and Barley, C&M Seeds, Canadian Seed Growers Association, FP Genetics, Germination, Nutrient Ag Solutions, Richardson, Sasqueat, Secan, Warburtons, Western Grains Research Foundation, and Seeds Canada. Without them, these scholarships would not be possible. Thank you to our audience for spending part of your lunch hour with us. Join us next week when Ali Roden tackles the topic of breeding with wild relatives. This is Marc Zienkiewicz signing off. Have a great day, everyone.
Bye.